Hello students, so in today's class we are going to continue with some standard types of function. In the last class we have seen a few standard types of functions and its graph. Hope you remember. Now in today's class we are going to see algebra of real functions. What is meant by algebra of real functions? We have seen what is meant by real function in the last class. What is meant by real function? A function defined on a real numbers, on the set of real numbers is called a real function. Algebra means what? The basic arithmetic operations, addition, subtraction, multiplication and division. So in today's class we are going to see addition of two real functions, subtraction of a real function from another, similarly multiplication and division as well. Now first let us see what is addition of two real functions. Now let f is a function from x to r and g is a function from x to r, where x is a subset of real number. Then f plus g is a function defined from the same x to r such that f plus g of x is equals to f of x plus g of x for all x belongs to x. So what do they mean by this definition? They mean if there are two functions defined on a real numbers, then the sum of those two functions will be adding those two values separately, is same as the sum of two functions will be same as adding the values of the functions, right? F plus g of x is same as f of x plus g of x. There is no different function defined over there, it is just the addition of those two functions. Same way subtraction also, f minus g of x is f of x minus g of x for all x. Next is multiplication by a scalar. What is meant by a scalar? A scalar is a constant, but that constant here we are going to take it again from the real numbers only. Then alpha f of x is nothing but alpha multiplied by that functional value at x, right? Nothing different there. If you multiply that scalar with the functional value, then you will get the alpha f of x under the mapping alpha f, right? Similarly, multiplication of two real functions, fg of x is f of x into g of x, multiplying two values under the function f and under the function g will give you the product of the functional value. So this is also known as pointwise multiplication. Next is quotient. Quotient means what? Division. F by g of x is nothing but f of x divided by g of x, provided g of x is not equal to 0. Always we will give this. Whenever we are talking about a quotient, we will say the denominator should not be equal to 0. The same way they have given here, right? So what we learnt here, the sum, difference, product, division, all of two different real functions is nothing but the sum of their individual functions, the difference of their individual functions, product of the individual functions and the quotient of their individual functions, right? Now let us see how we can solve the remaining problems which we left in yesterday's class. Second question, find the domain and range of real functions. This is very important, finding the domain and the range of the given functions. If you see the first subdivision, they have given f of x is equals to minus modulus of x. And before getting into the solution, whether it is mentioned or not, mostly we will stick on to real functions only. Real functions and the real valued functions. Actually, real functions itself is a broad group of functions. We are talking about the largest number system. We are not interested in the complex numbers. So think it's a real function, and in the question itself they have given they are real functions. Now f of x is equals to minus modulus of x, and modulus of x, modulus function we have learnt in the yesterday's class how it is defined. It is defined as x if x is greater than or equal to 0, minus x if x is less than 0. I explained. What does it mean? When we write a number inside modulus, in spite of its sign, we will take only the value. So if it is a positive value, if we have taken positive number, the answer is going to be the same number. If we are going to take the negative number less than 0, then it will be minus of that number, so that minus into minus it will become plus. That's why we have defined it as minus x, right? Now our function is minus modulus of x. So what we are going to do, we are going to apply minus in both these definition. What will happen? this x will become minus x if x is greater than or equal to 0, and this minus x will become plus x if x is less than 0. Now analyze this definition carefully. When x is greater than or equal to 0, it is minus x, which means if we choose a number from the domain, a positive number from the domain, then it will map to the negative number, right? If we choose a positive number from the domain, 0 or a positive number from the domain, then it will map to its negative. If we choose a negative number, x is less than 0, if we choose a negative number, it will map to the same number. In the sense, it will also be a negative number, right? So if we choose a positive number or 0, it will map to a negative number. If we choose a negative number, it will map to itself. Already it's negative number, so it will map to negative number only, right? This is what the definition says. Now come to the domain of f. Now what will be the domain of f now? This function is very well defined for all values of x. For all values of x including 0. Therefore, it is nothing but the set of all real numbers. For all real numbers, the function is clearly defined. Therefore, the domain of f is R. Right? Now, we will find what will be the range of f of x. What will be the range of f of x? Range means after applying the function, what answer are we getting? That is called the range. Now, just now we analyzed these answers. After analyzing these answers, what conclusion we arrived at? We arrived at a conclusion which says whatever number you choose, the answers are going to be only negative numbers. Yes or no? If you are going to choose a positive number also, it is going to map only to negative. If you choose negative number also, it is going to be mapped to negative number only. If you choose 0, it will be mapping to 0. So your answers will never be a positive number. It will be always a negative number. So how you can restrict your range? Your range can be minus infinity to 0. Other than 0, you won't get any positive number. Yes. Now how will you write your interval here? 0 is closed because there are possibility for your answer to be 0. You can get equal to 0. If you choose the x value as 0, your answer will be 0. Therefore, it is closed at 0. Closed interval we will denote it by box bracket. Hope you remember, we have learnt. Then it can be till minus infinity. In always minus infinity is open, right? Because we don't know whether we will get it or not. Right? When it is equal to, we will write box bracket. When it is less than or greater than, we will express it in the open bracket. Therefore, the range is open at minus infinity and closed at 0. Right? I will repeat the problem again. Kindly understand. These sort of problems are very, very important in relations and functions. They will ask you to find the domain and range. You should know how to analyze the function and find its domain and range. So first they have given you a modulus function. We know the definition of the modulus function. But only modulus function is not our question. It is minus of modulus function. So when we apply minus, the entire definition will change. Minus x if x is greater than or equal to 0. It will become plus x if x is less than 0. Now first question we need to find the domain. Domain means from first set, the values in the first set where the mapping is defined, right? So how the mapping is defined? The x values, you have to analyze the x values. Here the x values are from 0, less than 0 is also defined, greater than or equal to 0 is also defined. So the entire number line, for the entire number line the function is defined. Therefore, the domain is R. For the entire real numbers, the function is defined. Therefore, the domain of the function is R. Now, how we can find the range? For range, you have to analyze these answers. If we analyze these answers, we found that there is no possibility of getting a positive number. There is no possibility of getting a positive number. The answer will be a negative number or 0. Whatever the number you are going to choose, the answer is going to be only negative number or 0, right? Therefore, the range can be restricted as minus infinity comma 0. Again, it is very clearly seen it can be equal to 0. That's why we have closed the interval at 0 and open at minus infinity, right? Hope you understood. Let us move on to the next question. Now let us see the second question. Again, here also they asked you to find the domain and the range. F of x equal to square root of 9 minus x square, and it is a real function. It is defined on a real number system, right? But even then it is defined on a real number system, we have to check the domain. Because why are we talking about a domain? Why don't we simply write it as real number system? Because we know when it will become a function, no element in the domain should be left free. No element in the domain should be left without any image. Every element in the domain should have a image, right? So we have to restrict our domain. Every function will have its own restricted domain. The function cannot be defined for all real numbers. So that's why they asked you to find the domain and the range, right? When you check out this question, f of x is defined for all real numbers that are greater than or equal to minus 3 and less than or equal to 3. Why this is given here? Why it is greater than or equal to minus 3 and less than or equal to 3? Why it is not for all real numbers? Why? Because here the function is defined as 9 minus x square, right? 9 minus x square. So only if the function is defined greater than or equal to minus 3 and less than or equal to 3. Why? Because here the function is square root of 9 minus x square. If the x value is more than 3, for example say 4, then 4 square will become what? 16. 9 minus 16 you will get a negative number. Square root of negative number is not a real number. It is a complex number. You will be learning in your higher studies about complex numbers. Negative of a number, negative number square root is not a real number, right? Therefore, the x value cannot be beyond 3 on your number line, plus or minus 3. Because even if it is going to be minus 3, on squaring it we will get plus 9 only. So 9 minus 9 will become 0. Since here it is 9, this x cannot take value more than plus or minus 3, right? If it is some other number, accordingly you have to choose your x value. Hope you understood, right? If only x value is minus 3 to plus 3, it will be a number less than 9, because here it is square. When square that number, it will be a number less than 9. But if you choose more than 3, obviously when you are squaring it, it will become a number more than 9. If it is more than 9, since here it is negative, while subtracting you will get a negative number. A negative number inside square root is not a real number, right? It's a complex number. Therefore, the domain of f of x should be set of all x such that minus 3 less than or equal to x less than or equal to 3, and it can be equal to. Therefore, how you will express it in the interval? Closed interval minus 3 comma 3. And you should not directly list out here the values of domain will be minus 3, minus 2, minus 1, 0, 1, 2, 3. You should not. Why? Because we are talking about real functions. We are not talking only about the integers. There are infinitely many numbers between minus 3 and minus 2, minus 2 and minus 1. We know, right? We are talking about real number system. That's why we are expressing it as intervals. We are not expressing it in roster form. Okay, it can be any number less than 3. Even if you take a number 2.4 the whole square will obviously a number less than 9 only. So when you subtract that number from 9, you will get a positive number only. That positive number square root will be a positive number only, right? So that's why we are expressing it in interval. So what is a domain? Closed interval minus 3 comma 3. Now what will be the range now? Range means you have to analyze the answers. After substituting these values, what type of answer will you get? For that you have to check the maximum and the minimal value. So for every x belongs to the closed interval minus 3 comma 3, the function is defined now. So keep substituting the values and check how your answers are going to be. The maximum value 3 if I put, what will happen? 3 square is 9. 9 minus 9 I will get 0. This side maximum value minus 3. If I put minus 3, what will happen? Minus 3 the whole square is again 9. 9 minus 9 I will get 0. Right? So when I apply the maximum, when I substitute the maximum value in the domain, I am getting the answer to be 0, equal to 0. Right? So it is closed at 0. If I put the minimal value as 0, what will happen? 9 minus 0 is 9. Square root of 9 is 3, which is equal to 3. Therefore, the interval is closed at 3. Therefore, the range of this function will be closed interval 0, 3. This is how only you have to analyze a question and you have to choose your domain and range. If we do more problems on this, you will be get familiarized and it will be easy for you to find the domain and range, right? Now let us see the fifth question. They asked you to find the range. First question, f of x equals to 2 minus 3x and the function is defined x belongs to R and x is greater than 0. They have clearly given x is greater than 0. Now we have to analyze the answer. Start from this, x is greater than 0. Now our aim is we have to bring this over there. Alright, if x is greater than 0, what we can, now we need 3x. Now multiply 3 on both sides. 3x is greater than, 3 into 0 is again 0 only, right? I am multiplying 3 on both sides. So 0 into 3 is 0 again. So 3x is greater than 0. But we need minus 3x. So keep multiply minus on both sides. So minus 3x, when you multiply minus on both sides, what will happen? The greater sign will change to less than sign. So minus 3x is less than 0. Then we need 2. So add 2 on both sides. What are we doing here? Adding 2 on both sides. What will happen? 2 minus 3x is less than 2. What is 2 minus 3x? Which is nothing but your f of x. So f of x is less than 2. And we know this is a real function. Therefore, what will be your range? It should be less than 2. So this is your number line, right? 0, 1, 2, this side it will go on. Minus 1, minus 2, this side it will go on. So less than 2 means what is your range? Your range is this, from here to here. Yeah. So this side end we don't know, so it is minus infinity till 2. So minus infinity comma 2. Now you have to decide about the interval whether it is closed or open. Now it is less than 2, it is not less than or equal to 2. If it is equal to 2, it will be closed. Since it is less than 2, it is open interval, open at 2, and this side also open at minus infinity. So your range is minus infinity comma 2, right? Now let us see the next question. F of x equals to x square plus 2. X is a real number, right? The same way we need to bring out this question. X is a real number, therefore obviously x square will be always greater than or equal to 0. Even if you put a negative number, when you square it, it will become a positive number only. Minus into minus, it will become plus, right? So x square is greater than or equal to 0. We need plus 2. So add 2 on both sides. When you are adding, the sign won't change, but when you are subtracting, the sign inequality sign will change. When you are subtracting, inequality sign will change. Greater than will become less than will become greater than. But when you add, the sign won't change, right? So x square plus 2 is greater than or equal to 2, which is nothing but f of x. So f of x is greater than or equal to 2. Okay, so what will be your range now? 0, 1, 2, this side minus 1, minus 2, this side it will go on, this side it will go on. It is greater than 2. So your range is now from here to here, right? So greater than or equal to 2. So 2 to infinity, open at infinity, since it is equal to, it is closed at 2, right? Hope you understood. Third question, f of x equal to x, where x is a real number. F of x is mapped to itself. Whatever value you choose, it is mapped to the same value. Therefore, obviously the range will be the entire real number. When you choose a real number, when it is mapped to itself, it will be the real number again. Therefore, the range is real number only, right? Now we will move on to miscellaneous exercise. Your first question is to check whether the function f and g is a function or not. Sorry, the first question in miscellaneous exercise, what they have given is, they have defined two functions, f of x and g of x. They asked you to show that f is a function and g is not a function. We know when we will call a relation as a function. When we will call a relation as a function, it should satisfy certain conditions. What are all those conditions? It should, first of all, every element in the domain should have a unique image in the codomain. It should not have more than one image. Second condition, it should be defined for all the elements in the domain. Now, none of the element in the domain should be left free without any images. If it satisfies these two conditions, then that relation will become a function. So now we are going to check those two relations, right? Now if you see the first question, f of x equals to x square for 0 less than or equal to x less than or equal to 3, and 3x for 3 less than or equal to x less than or equal to 10. Now if you observe and analyze this definition, if you see 0 to 10 continuously they have given, but 3 is repeated twice. Here is also less than or equal to 3, here is also less than or equal to 3. So, at the point 3, you can take either this definition or this definition, right? That is what the meaning of this. So, let us check at the point 3 especially, what answer are we arriving at, right? So, it is observed that 0 less than or equal to x less than 3 varikum and the problem kadiyadu. So, less than 3 varikum we can take this definition. And from 3 to 10, greater than 3 less than or equal to 10 varikum in the definition. Adukku endha issues kadadu. But at the point 3, ingiyum equal to 3 irukku, ingiyum equal to 3 irukku. So at the point 3, what will happen? Let us analyze. So at the point 3, if I take this definition, x square equals to x vandu 3. So 3 square will become 9. But suppose if I take this definition, what will happen? 3 into 3, again I am ending with 9. So, whichever definition I choose at the point 3, it gives the same answer. Therefore, the images are unique only. The images are unique and hence it's a function. Right? And obviously, we know for every element from 0 to 10, if we apply this definition, we will get one answer that will be a real value that will be available in the codomain. Our aim is to check for every element 0 to 10 whether it is defined uniquely or not. Yes, it is defined uniquely, therefore it is a function. Let us see what happens to the function g of x. Now if we check g of x, the definition says x square is 0 less than or equal to x less than or equal to 2, 3x for 2 less than or equal to x less than or equal to 10. The same way it is defined. Now again for equal to 2 there are two definitions. So let us check at x equal to 2 what happens here. If we see, if we take the definition x square at the point 2, we are getting the answer as 4. But if we take the definition 3x at the point 2, we are getting the answer as 6. Both are not equal. We are not getting unique answer. So which says the element 2 in the domain corresponds to 2 images. So this is not a definition of a function, right? It should correspond to a unique image. Therefore, it is not a function. Hence, we have shown that f is a function and g is not a function, right? Hope you understood. Now let us see the second question. Given f of x equals to x square, they asked you to find f of 1.1 minus f of 1 divided by 1.1 minus 1. This is similar to the problems which we have solved in previous classes and all. F of 1.1 means in the place of x you have to substitute 1.1. Instead here they have given decimal value since we are talking about real functions. That's it. But the procedure is same. So in the place of x, in the definition of x, we are going to put 1.1 x square. So 1.1 the whole square minus 1 square divided by 1.1 minus 1. What is 1.1 the whole square? 11 square, right? 121, but you have to place decimal after 2 digit. So 1.21 minus 1 divided by 1.1 minus 1 is 0.1. So after subtracting, divide it, you will get the answer. How you will get 2.1? You know, right? Make it as a whole number by multiplying with minimal 10 powers. If I multiply this by both numerator and denominator by 10, this will become 2.1 divided by 1. So the answer will be 2.1, right? So next problem, if you see, find the domain of f of x. They have given you a rational function. So when this function is defined, we know the main criteria for the rational function, the quotient function, is the denominator should not be equal to 0. So when the denominator is equal to 0, the function is not defined. So our aim is to check the denominator should not be equal to 0. So we are going to go with the controversy. We will check at which points the denominator is going to be 0, and at that particular points the function is not defined. Hope you understood. எப்போவுமே when you have a quotient function, denominator 0வா ஆகக்கூடாது. 0 ஆயிடுச்சுன்னா அந்த ஃபங்க்ஷன் அந்த இடத்துல டிஃபைன் பண்ண முடியாது. ஸோ நம்ம இங்கே என்ன பண்ண போகிறோன்னா, எந்த பாயிண்ட்டில் denominator becomes 0 அப்படின்றத கண்டுபிடிச்சி அந்த இடத்துல மட்டும் the function is not defined, otherwise the function is very well definedன்னு நம்ம சொல்ல போகிறோம், right? So f of x is not defined when denominator is 0. அப்போ எந்த இடத்துல 0 ஆகுதுன்னு we are going to find. If we equate the quadratic polynomial to 0, we know how to find the two roots, right? So kandupidichona, we found that at x equals to 6 and 2, the polynomial becomes 0. அப்போ அந்த இடத்துல மட்டும் the function is not defined, but in the entire real number system the function is defined. ஏன்னா அந்த பாயிண்ட்ல மட்டும்தான் denominator 0 ஆகும், right? So we found that at the point 2,6 the denominator becomes 0. அப்போ entire real number systemல அந்த ரெண்டு பாயிண்ட்ல மட்டும் the function is not defined. அப்போ domain எப்படி எழுதுவ? the real number system minus 2,6. இந்த real number systemல இருந்து இந்த 2,6 மட்டும் omit பண்ணிட்டா மீதி எல்லா பிளேஸ்லையும் the function is defined. So this is the domain R minus the set 2,6. Right? Hope you may be finding difficult in finding the domain and range, but if we do many problems of this kind, you will get familiarized towards it, right? So in today's class we have learnt what we learned. We learnt about algebra of real functions, and then we solved problems fully based on finding the domain and range of the given function, and to check whether the given defined relation is a function or not, right? So with this, let us wind up the class, and I have given you few problems as homework, finding the domain and the range, additional problems. Do it, practice it, and if you are not getting the answer, kindly contact me, I'll explain you, right? These problems are of the similar type which we have solved right now, of the same kind only I have given, so you can very well do it. After completing, post it in the group. Okay, thank you students.